Good day, everybody. My name is Peter Husey, and on behalf of the Cyber Innovation Center, Louisiana Tech Research Institute, and the Mitchell Institute of Aerospace Studies, I'm Peter Husey, and I want to welcome you to this, our 20th Nuclear Triad Symposium, the title of which is Second to None, Working Together to Modernize America's Nuclear Deterrent. We are very fortunate today to have Navy Captain Ethan Proper. He is the Missile Branch Head in the Navy Strategic Systems Propulsion Office, and Navy Strategic Systems Program is responsible for the development, production, and life cycle support of the Navy's Fleet Ballistic Missile Strategic Weapons System, which includes both the submarines and their D5 missiles. In his career, Captain Proper has sailed in ballistic missile submarines, repaired and overhauled nuclear subs, and he has worked closely with the United Kingdom's Ballistic Missile Submarine Program. Captain, I want to thank you on behalf of our sponsors for taking the time to speak with us today. And I'd like to start by giving you the opportunity to update us on the Columbia-class submarine program. Over to you, sir.
Thank you, Peter. I just want to say what an honor it is to address this panel, address this forum. I really appreciate the opportunity to speak with you today. As you said, and I think this is some background that a lot of people recognize already, but I'll just reiterate the fact that SSP is the lead acquisition agent for the Trident II D5 strategic weapon system. We've been delivering missiles to the fleet, to the SSBN fleet for over 65 years, ranging from Polaris to Poseidon to now the Trident via C4, D5 life extension programs. And just now and most recently, as we step into the LE2 development, which we have now just embarked upon in the last year or so. Some interesting context just for the audience. Trident delivers over 70% of the nation's deployed warheads, and we deploy 100% of the United Kingdom's continuous at-sea deterrent program. So we really depend upon the modernization of not only the missile system, but also the associated submarine that carries that weapon system. And so, I think it's fairly open knowledge. Navy is currently embarked upon new construction activities for the Columbia class, and similarly in the United Kingdom with the Dreadnought class, which similarly hosts a common missile compartment. So it's a common shipboard architecture for the strategic weapon system, as they're both going to carry D5 LE into the future. So with respect to Columbia, I will tell you that PMS 397 is the lead for the acquisition of the Columbia class, and Captain John Rucker is the program manager for that effort. But SSP is tightly coupled to that effort in the strategic weapon system delivery area. We have actually already started to deliver hardware to those programs, both to BAE Submarine Systems, who is constructing those submarines in Barrow and Furness in the United Kingdom, and up to Electric Boat in Groton. So we have already started hardware deliveries for some very specific shipboard systems. And we stay very involved in the status of those construction efforts. There's also a very important related activity with Columbia that I think some people are aware of, and it's called the SWS Ashore activity. So SWS Ashore is the Strategic Weapons System Ashore. It's located actually at Complex 25 in Cape Canaveral, Florida. It's a capability that we have not had historically at the program. It is an integrated land-based test facility with a replica of major portions of the strategic weapons system, both the missile control central portions and the HMNE, the hull mechanical and electrical components related to the missile tube, that give us an opportunity to proof out the program, proof out systems, capabilities in the future, and also proof out the design of Columbia and Dreadnought, so that when we get to the first of class, we've learned a lot of those lessons prior to getting there. So With respect to Columbia and Dreadnought, SSP is absolutely plugged in, working closely with PEO submarines and PMS 397 to bring that capability forward. The more recent effort and the more SSP-centric effort is the D5LE2 design activity. So within LE2, we have just now initiated some of the systems architecture trade studies that are going to set the groundwork for how we execute LE2 design and development moving forward. And it moves through a systems requirement review in the mid-20s. So, we're very excited to get that effort kicked off. And the workforce is really aligning to support that effort. There's a similar thread related to LE2 that I wanted to mention, and it's this idea of digital transformation or cultural change. And SSP recognized a few years ago that we have been operating in this mode of sustainment for many years, or obsolescence management related to the existing weapons system. So we have not seen a development of the magnitude of LE2 for some time, really going back to D5. And the people are different, the processes are different, the technologies are different in all of that. So we have challenged our workforce to conduct, again, the term digital transformation, to incorporate modern design methodologies such as model-based systems engineering or DevOps or agile software development. There's a whole range of these activities: adaptive manufacturing, 3D printing, augmented or virtual reality, all can sort of lend themselves to improvements within our ability to either spiral faster, design faster, and work faster in order to get to a solution faster on LE2. So we're very excited to see that moving forward. It's really a major initiative for us, and we see a lot of good things coming out of that activity already. The last thing I really wanted to mention within my remarks is the fact that I will tell you that within the Navy, Air Force, MDA community, this joint community, we have a stronger and healthier collaborative environment that has ever existed before. You obviously have the Air Force with GBSD, you have MDA with Next Generation Interceptor, a lot of common technologies in those areas, a lot of common use cases in those areas that if we work jointly, we can really leverage what each other is doing effectively and kind of learn from the mistakes of other people. And at the same time, it's a great opportunity to jointly develop technologies so that if a technology perhaps is not ready for Navy when we need it, it is being developed so it's ready for Air Force, after the fact, or whatever the staggering of the development activities are. So, a lot going on in the program. Columbia and LE2 certainly very important focus efforts for us, and we're excited to support the warfighter. Over.
Captain, thank you so much for that. We went through a couple questions that we would like to discuss. Let me start with one. With our adversaries' very visibility, testing, and fielding new capabilities, what, in your view, is the biggest challenge or barrier to your organization being able to move at what General Hyten has called the speed of relevance?
You actually remember this. I was in the United Kingdom when General Hyten had made a number of remarks related to, at the time, it was Columbia acquisition and GBSD, although, full disclosure, I'm sure as many of his remarks could have been directly applied to LE2 as well. It's just LE2 wasn't quite at that point in the discussion yet. To me, there's sort of two parts to this answer. There's what I talked about in my opening remarks related to cultural change. You have to recognize fairly early that organizationally, the sustainment mindset is different from the development mindset. This idea that, yes, from an obsolescence management perspective, you may have to deliver a form, fit, function solution to some hardware design that already exists. In other words, you may have to restart that production line, which may make you look at that design and refresh that design based on components that are available today. That discussion does not allow for a lot of sort of open development, a lot of architectural change within the system. And so the skill sets involved in that are very different from the skill sets involved in large scale development. And that's why, like I said, roughly 3 years ago, from a Navy perspective, we recognized that we needed to transform. Draper Laboratories had already instituted some of this via the guidance, recent guidance development with model-based systems engineering, and that sort of evolutionary approach to design is now spreading through the enterprise. We're pushing our prime contractors hard to not wait for LE2 development, push those practices into today's processes, show us what you can do today, learn from mistakes, and that way as we enter LE2, those processes will be in place. Again, not only for model-based systems engineering, but also for agile software development and the other type of skills. So that's sort of this cultural aspect of it. The other issue is you need to be smart about the way you establish these systems architecture trade studies. You need to recognize the fact that D5LE2 architecture is constrained in some ways. I mean, we want to be fitting to, we need to be fitting to the missile tubes that exist on Columbia today. They're not going to be different missile tubes. Fundamentally, the shipboard architecture will be similar. So it sets certain constraints on the design. So the challenge becomes, how do you set trade studies up so that you're going to identify technologies as a result of those trade studies that can reasonably be delivered in the timeframes that we have for LE2. And if you make some of the weighting factors for those technologies, ability to integrate with pull-through LE, then you can influence those trade studies so you have a more achievable solution in the timeframes that we have.
Let me ask another question that has to do with the SSP's acquisition process. You're pursuing an acquisition approach rather than a traditional competitive design build process. For our participants, explain what you mean by that and the significance of what it is you're trying to do.
So the approach, the acquisition strategy for LE2 is what we would call with an SSP a SPALT-based approach, or an SSP alteration-based approach. So the question is this a traditional DoD 5000 based or a traditional acquisition strategy? Well, in many ways, yes. The truth of the matter is SSP's alteration approach is derived from the DoD 5000 series, from DoD level guidance on how to do acquisitions. But I'll say that the salient detail that I think we recognized early on in this is actually similar to my discussion earlier. That the LE2 design is constrained in the sense that it features a significant amount of pull-through capability technology components from the existing LE design. And so again, when you look at boost rocket motors, which will use the same boost rocket motors, when you look at the shipboard architecture with respect to the launcher subsystem or the navigation system, largely it's the same capability, whether you're talking LE or LE2. It sets constraints on the design of the program. You realize fairly quickly that you're not talking a new design. You're not talking the type of development that would lend itself to, open aperture, all competition, all providers, because it really is an evolution of the D5LE weapon system. So, the word traditional is interesting because when you say traditional acquisition approach, I think things like systems engineering technical reviews, SRR, TDR, CDR, or proper hooks in the design process to ensure quality assurance or proper governmental oversight. And all of those features exist within the SPALT process, SSP's alteration process. And really that sort of leads to, I guess, the last part of this answer, which is we, SSP, have effectively managed the SPALT process, which is a configuration management approach for the weapon system for really the life of the program, but I'll say specifically the last 20 years. We have come through the D5 to D5LE transition. We have come through multiple shipboard increments, which are major to minor obsolescence management activities with respect to shipboard systems within this SPALT process. It's something that we are very familiar with. It's something we have managed in the past, and really at the end of the day, from a systems engineering perspective, it's analogous or derived from a traditional acquisition process.
Let me ask you another question. What technologies or industrial base issues cause you the most concern about the D5 LE2 development?
Right. So I will tell you that some of those are many of the same challenges or what was the word you used? Concerns that we have today. There, even within D5LE, there are very unique technologies or capabilities that the D5LE weapon system possesses that we need to maintain within the industrial base today. And a couple examples are boost rocket motors, solid rocket motors. We recognize that the industrial base capability to deliver solid rocket motors with 1.1 propellant needs to be maintained. So we have previously, and it is currently being executed today, entered continuous production on solid rocket motors. So we will continue to build those motors through the near future and into the LE2 program. And those rocket motor stacks will be used for both LE and LE2. So one example. Another example is radiation hardened components. As you can imagine, a fairly specific technology to, I'll say, the strategic deterrent mission is the ability to deliver electronics packages that have the opportunity to operate in a radiation heavy environment. So, those are capabilities where we have either taken action with the industrial base or taken action really at the OSD level to protect vendors and maintain those capabilities. So I think that's the first one. Concern. So again, I feel like I'm beating a drum here, but I'll just say it one more time that we have not done a development of this magnitude for quite some time. So I think we do have concerns about our traditional partners' abilities to quickly turn in a design or developmental basis and spiral or iterate quickly in order to get to technical solutions. And again, that's why we're pushing for this digital transformation and moving forward and again, agile model-based systems engineering. So the third category concerns, I would say that coming out of LE, we did recognize, even though LE was not LE2 from a scope of development perspective, there were many lessons learned from LE related to restarting legacy production lines on hardware that has not been built for 20 to 30 years and the necessary refreshes of those designs. So we really are striving to get better on some of those lessons learned, to program the right amount of time into the schedule, to have the proper engagements with sub-tier vendors, to ensure that those conversations occur early so we don't see surprises in the development process late in the game.
Captain, you and I had discussed earlier that the SSBN 726 and Trident C4 were the last, one of the previous procurements and acquisitions. You had both the development and integration because you had the submarine and you had missiles. You had to integrate them. How have you and SSP, how have you at SSP and NAVC leveraged the lessons from those two acquisitions? And can you give us some specific examples?
Right. So it's kind of interesting. I would have, when you say lessons learned, the ones that are sort of most fresh in my mind are these lessons learned from LE design, actually, specifically. I wouldn't go back to C4 and Ohio, but so one of the issues with C4, and I think many of the people have heard the term D5 backfit, or this idea that if you look at how the C4 to D5 acquisition program was built versus the Ohio construction program, those programs were linked. So they were linked at the, I'll say that the delivery of Ohio was supposed to be coincident with the delivery of the D5 weapon system.
Yes, I remember, yes.
Right, so when they became unlinked, you had a choice. You could either delay one capability, either the submarine or the weapon system, or you could make changes to one side or the other interface so that those systems could be delivered. So for example, the Ohio could be delivered with C4 and then backfit to hold D5 while it was ready. Well, C4 and D5 had significant shipboard architectural differences related to a launcher, some of the shipboard systems that drove significant cost and time into the backfit activities associated with upgrading Ohio or the relevant hulls that were not able to host the D5 missile. So there was a lot of cost on the back end. So LE2 recognized that, and LE2 is essentially being built such that we can, I'll use the term, hitch a ride on whatever Columbia class submarine is available at the time LE2 is available. So it accounts for the fact that whether we see slight fluctuations in the LE2 program or in the Columbia class shipbuilding schedule, there will be a boat available to conduct test flights on, and we will not be in this bind where massive changes need to occur on the shipboard side, i.e. backfit level changes to support the LE2 missile. So I think that's, to specifically address your question, that's really sort of one example. I will tell you that I was actually on the program in 2008 for the pre-acquisition activities for Columbia, specifically focused on the common missile compartment. It was called SP29 at the time, and then evolved into PMS 397 when the program office formally stood up. But there was a lot of capital exerted to look at Ohio both from a producibility perspective and from a sustainability perspective. And some of these concepts I won't go into detail because truthfully they've been covered a lot before. But this whole ideology of modular design, which Virginia featured, and now Ohio is going to feature, this idea that it's cheaper and more efficient to do work when you're in a production floor or a module than it is to do when you're inside a pressure hull is sort of a common theme with the Ohio class. So that's kind of another lesson learned. And I guess the last one I would give you is, again, I mentioned at the beginning, is early test via an integrated test facility that did not exist for Ohio. We had something called the whistle but up in Groton, but slightly different from the Swiss ashore in Cape Canaveral, which literally is, it is a replica of the strategic weapons system, and can tactically reproduce many of the things we do in the weapons system today.
You had mentioned earlier in your remarks about the collaborative working groups.
Right.
And I know you have to kind of stay at kind of a certain level when you're discussing them. What's your sense? Can you talk to us about what continued collaboration you envision between the United States Navy and Air Force?
Yeah. So I anticipate continued collaboration equivalent, or at least equivalent, to what we already have in place. I think I mentioned in my opening remarks, but we have currently a very healthy collaborative environment under what's called the OASG, or Overarching Steering Group. The steering group has essentially divided down the functional areas that would relate to both Navy, Air Force, and MDA. And we are actually working within those functional areas to make sure that we are leveraging what each other are doing, learning from our lessons, from each other's lessons, and just just to give you some relevant examples. And again, this kind of makes sense. There are certain subsystems within any missile that there are commonalities, right? So you look at propulsion, there are opportunities; guidance, there are opportunities; reentry, there are opportunities. There are also areas such as mission assurance or logistics associated with the weapons system, where we should or could be doing things similarly, could be learning from what each other does. So we're doing that today. One thing I do expect to see, and I'll tell you, my previous job prior to being the missile branch head was actually being fire control and guidance. So guidance, Draper Laboratories in our case, who is the acquisition agent for the Triad guidance system, is working closely under this OASG activity on joint technology roadmaps, where the R&D efforts associated with guidance could be linked such that we are all utilizing not a common pool of money, but building technologies that leapfrog off of each other. And again, it goes back to my opening statements where I said, yes, the technology may not be ready when Navy needs it, but if we're all jointly investing, it will be available when Air Force needs it. And that sort of logic continues, whereas yes, Air Force may have invested in technology that may not be ready when they need it, but it will be ready for Navy. And then you pull MDA in there. It's just really, in this world of great power competition, it would be illogical not to work together when you have such common underlying architectures.
What's your sense of, I don't know if you can tell me the date, but the D5 is going through a life extension number 2.
Right.
Minuteman went through a number of life extensions, particularly starting in the mid-1990s. And basically the estimates are it can go through maybe 2030 because the law requires it to do that, but you're then getting right at the margin, and that's why GBSD has to come in. What's the time frame you see the life extension lasting for the D5? Because you're talking about a submarine that's going to last what, through 2075, 2080, which is pretty extraordinary.
I'm not sure how detailed I can go on yours. I think I can safely say that it's public knowledge that 2084 has been advertised as the completion of the current Columbia class, and I don't quote me on that. I may be off by.
I think you're right. I think Admiral Benedict and Admiral Wolf have used that number.
Right. So recognizing that the Columbia class will exist until 2084, we SSP, we've used this mantra to say we're only halfway there, right? So 1960 roughly, looking at 2084, we're kind of the halfway in the program. So LE2 will be designed to get us closer to 2084, and then we will have certainly an additional life extension or capability, whatever the nation needs to, again, Polaris, Poseidon, Trident, and continue to support the warfighter and whatever the missile system dictates.
One of the things we talked about earlier before you came on is the time it takes to go from beginning a program like Polaris, 1957, the missile achieved IOC in 1960. I lived and breathed Peacekeeper for 6.5 years from the time I started working on it to the IOC of October 1986. It was interesting, General Casey of the Ballistic Missile Office in 1974, when asked by Congress, when will you deploy the MX? He said October 1986, which General Casey recently passed away, but he was an extraordinary visionary. But question is, what's the reason it takes such time to go from the original work to IOC? And similar to Columbia class, we're talking about it's working now. We were doing it. It won't come into the water until what, 2032. And because critics often say, well, why do you have to take so long?
Yeah, it's a fair question. And going back to General Hyten's comments, a few years ago, I would say that even though if you look at LE2 and you look at the timeline that we have laid out between, I'll say development, and I'll define that as preliminary design review to the first flight test, we're talking roughly 5 years. Which I think we have tried to be as aggressive as we think is realistic. I certainly think that an argument could always be made that that's not fast enough. But I will say this: Trident 2 D5 LE2 is not Polaris A1, and I certainly will not do anything to discredit Red Rayborn and the accomplishments of many hardworking and very intelligent men and women who delivered Polaris in a political climate which was the Cold War, deterrence of Soviet aggression, with a completely aligned government behind them to deliver that capability. But I do think we recognize that the climate, the acquisition climate we work in today is different, both from statutory and regulatory perspective. The adversarial climate we exist in is different. Yeah. The requirements and capabilities that exist in LE2 today, they weren't even thoughts in 1960. When you start talking multiple independently targetable reentry vehicles, you talk astro-inertial guidance systems capable of conducting star sightings and performing control system adjustments based on the inputs from the stars. You talk computing environments capable of executing the fire control problem and all associated targeting. It's a different type of problem. And then when you look at just pulling through today's technology and saying, okay, base requirement is pull through today's technology, and maintain demonstrated systems performance, which I think we would all agree is fairly high today. But then you say, well, then let's open up the design so that what comes out of LE2 is also flexible and adaptable and meets not only the warfighter needs of 2030, but also moving forward for decades to come. It is a challenging problem and it does take time. So I think the right answer is we need to get faster, but we are attacking this as aggressively as we can, and it is a hard problem.
Well, again, I want to thank you, Captain, for being with us today. As I said, this is the 20th Nuclear Triad event we have had since 2011. We do one in Washington, D.C. every year with the Minot Task Force, and we do one outside of Washington, D.C. at a nuclear base or an association with a nuclear base. And this is the first time we've ever done anything with Global Strike. But I do want to say that I have tentatively talked to your boss, Admiral Wolf, and he said, yes, we should go to Crane, Indiana next year for the third time.
Excellent.
And have another Triad event there, which I hope perhaps you and Captain Williams will be able to join us with. But again, I want to thank you on behalf of the Mitchell Institute of Aerospace Studies, the Cyber Innovation Center, and Louisiana Tech Research Institute, and of course, our friends at Global Strike Command with whom we are doing this cooperatively. Captain Proper, thank you so much for your remarks. I look forward to having them posted December 10th, which is when our conference formally begins. And again, thank you on behalf of our sponsors to you and SSP for taking the time to talk to us today.
Thank you so much, Peter. It's really been an honor.
Thank you, sir.
Thank you.
Thank you. Take care.